This conference will now be recorded.
Over to you, Seth. Thank you.
Okay. Yeah. Thanks a lot for having us here as a guest today and present our, let's say, latest product vision, which we are planning to release soon, which is so-called the SAP Warehouse Robotics solution. It's a plug-and-play robotics integration, and we would like to dig into it in a few seconds. So first of all, my name is Florian. I'm since the beginning of the year the new head of EWM product management, and yeah, so let's get started into this topic. Short disclaimer because it's a product which we plan to release. And what's the agenda of today? First of all, we would like to bring you a little bit of an explanation what we consider an agile robot. You will see in some minutes that robots and robotics in warehousing is nothing completely new. Then we would like to have an eye on the architecture of this new solution and even look at the roadmap. So let's go to the definition, let's say, what we consider to be an agile robot. Robotics, as mentioned in the warehousing, is not a new story. It's already started in the 90s, and this picture you might know or recall in your mind. This is an automated high bay. So automated high bays are there for quite a long time. I think the beginning was always about, let's say, pallet high bays with that automated cranes, and usually we call it material flow systems connected to that to basically store pallets or then later on even boxes in a very efficient way. The downside of this was that this was usually a huge invest, and these, let's say, automated cranes could not directly coexist in the environment where the users are operating. So you need a lot of fences around to grant, let's say, the safety of the users, and it needs to be somehow locked in a very controlled way. It was a huge invest, and yeah, it was not as flexible, not scalable enough. And I think that is basically where we are now. Let's say beginning of the last couple of years, we started, let's say, this product development in 2021. And here we basically aim for these autonomous mobile robots. The difference here is that they could basically coexist. So you can work together with them. You don't need these heavy fences. You can easily scale. You can start, let's say, with 1, 2, 3 robots, which basically could even follow you. You can perform a pick, you throw it onto the robot, and he would further process it, for example. And so even one of these dedicated robots is far less expensive than this whole-blown huge automated high bay system. And even from a software integration part of view, back in the days it was a long software journey to get this ramped up and integrated into the backend landscape. And this is basically why would we like to use these autonomous robots? With them, you could easily react on a dynamic demand. So, I mean, COVID was showing us this quite obviously. The demand, especially in the big retailers, right, in the online retailers, in the e-commerce business, was basically exploding overnight. And labor is a very valuable good, right? I mean, you cannot easily find new workers everywhere. So it is even critical for the future that we incorporate these new technologies and ramp up not robots. And we can even think about concepts in the future of having kind of rental concept of robots so that you don't really buy them. You just have a peak. You basically, it gets even predicted maybe in the future, and your robot supplier basically provides you with, let's say, another 5 robots for the next 3 months where you have a certain peak, maybe a seasonal peak or something like that, and you can quickly adapt that into your warehouse operations. But even warehouse processes can change. We will hear or see later on that we will have different, let's say, back-end systems where we would like to connect our warehouse robotics solution. And what is one of our first areas where we see these massive changes of warehouse processes is when we look into the manufacturing area. Here, basically, we come from, let's say, this classical line setup. So you have a beginning of a production line, and then you have certain steps until the end, and then you receive your finished product. But this behavior is changing. So we are we cannot anymore do, let's say, a static supply to this production line. This goes more and more into the direction of a kind of modular production. So you have production islands, and they can fulfill different activities in a complete different sequence. And if you consider, for example, this process change, then it should be the robot system should be capable to adapt to that. And if you have a static automated high bay or an AGV which can only drive on given routes, that will be quite hard. But with these autonomous robots, you could fulfill that easily. And the last thing which comes most of the time along, let's say, even with these kind of process changes, might be even changes of the warehouse layout as such. You can think about simple cases where you just build a rack somewhere in between. Yeah, and with a static road, you cannot go around that, but an autonomous mobile robot with all that LiDAR sensors, which are kind of aware of their environment, they basically scan it, and you can just place something in front of that. They know where they should go to, and they just bypass, let's say, this new built rack, for example. All this basically drives the way or the road into autonomous mobile robots. Autonomous mobile robots are part of the solution. Autonomous mobile robots make automation affordable. Yeah, I mean, as mentioned, a robot is less expensive than a whole full-blown automated warehouse with conveyors, with static conveyors, for example. They are human safe, so you could directly step in front of this robot and he would just stop or go around you. And as mentioned, he can even adjust to changing environments. So if you place a pallet somewhere, so maybe a forklift driver just drops a pallet somewhere, he's not stopping in front of it. He's basically trying to find his way around that. I mean, you might be used to these autonomous robots even in your private life. If more and more people get these Hoover robots at home or even mowing robots for the garden, and even there, I mean, if you place a chair or whatever in between, he's not stopping operational, so he's basically trying to find his way autonomously around this chair. But we have to admit there's still some challenges which we see. So there's an expensive system and process integration. So still, let's say the integration to different backend systems or existing backend system could be quite expensive. And if you start to build kind of a first robot fleet with one vendor, then it can easily turn into a kind of vendor login. So if you would like to scale, it's like you buy a starter packet, yeah, you get the first 3 robots for a very good offering, but then you basically see the benefit and you would like to scale quickly, and then you have to purchase additional robots, which might be quite costly, and you don't have the freedom anymore to choose other robots, for example. And even from an IT strategy and governance point of view, we just got the feedback from our customers. They would not like to build, let's say, the next world of own legacy integration here. So you would like to be hardware vendor agnostic so that you can choose for different purposes, for different environments, different robots, and manage them, let's say, jointly and distribute even the workload jointly. And here warehouse robotics comes into the game. So the key is to easy onboard robots into that environment, into our solution. We would like to ad hoc onboard them, and we would like to have manage a heterogeneous fleet. So as mentioned, let's say a pallet robot which can move a pallet, which even can move heavy loads, for example. And you have on the other side, let's say small box robots. And all this should be managed in warehouse robotics. Here a little bit a graphical explanation what I just mentioned. If you have certain areas, you decide to purchase a robot from type A, and you say like this area could be operated by the robot, and you make good experiences, you see the efficiency and the benefits of using a robot, and you would like to roll it out to maybe your heavy box area. But therefore, the robot type A is not usable or could not be used because he's not strong enough, he could not lift that weight, and you need to purchase another robot from another hardware vendor. And even that should be then integrated, and you should not have different platforms to basically distribute the workload and the warehouse tasks to the different robots. So you should not make your mind around it. You simply should onboard it with certain capabilities, and then the system should basically decide and distribute the work to the different robots. And we didn't design it in, let's say, a kind of ivory tower scenario. So we basically did that in a proof of concept with one of our customers, Bechtle, and they mentioned exactly that. They are facing this explosion in demand and order volumes during the COVID pandemic. And even they are located in a geographical region where there's an extremely low unemployment rate, right? So it's really hard to find new employees to say like, oh, we have a bigger demand, we need 10 more people. Yeah, it's not so easy in that area. So they really had to look for alternatives. And the answer was here again to come down and say we need to utilize the latest Industry 4.0 capabilities, or 4.now as we call it, because the time is right now and these robots are available, and there's a lot of different hardware vendors. And they decided on one of these hardware vendors, which is Mir, and yeah, did a proof of concept and integrated their robots into their warehouse processing. So they have 12,500 stock keeping units. It's a 25,000 square meter storage area, and they basically estimated an yearly return of invest from robots project after full implementation, roughly about 30%. So if you are interested in how this could look like in reality, and so basically we have already proven that, and based on the experience we gained there, we build now our warehouse robotics solution. If you are interested in that, here's the link on YouTube. It's freely available in English and in German, so you can watch that and see how it looks like in a real life environment, and how very interesting is here, I think, how human resources can coexist and co-work together, let's say with the robots. So you really see forklift drivers operating next to this autonomous robots. By saying this, I would like to hand over to Christian to explain you more on the technical details, the architecture, and the roadmap.
Thank you, Florian. Could I please get the
Yes,
presenting rights again? Then I would start sharing. I think I need to be appointed to the presenter again.
Sure, let me do it.
Mhm. Okay.
You're now the presenter.
Yes, I started sharing, so please let me know if you can see it.
yes, we
Yes, we
can see
can.
it.
Okay. Yeah, so thank you, Florian. I will take it from here. I will now try to give you a bit more insights on the actual product that we are talking about of warehouse robotics. This is to just start with the overview. Uh, okay. Okay, now it's working again. PowerPoint just stopped working for a second there, but it's back. Okay. Um, so as you can see, this is probably very interesting to know. As Florian said, this is a product still under development. It's not released yet. So middle of 2022, so actually in May, end of May, that's when the first release is planned. And in the very first release, we focus on this process that you can see right here. So that would be processing handling unit tasks for EWM warehouse orders. So that can be within multiple areas of the warehouse. That can be during goods receipt, that can be during goods issue, that could be internal movements, production supply, whatever. If we're talking from an EWM perspective, the only thing really required as a prerequisite to connect to warehouse robotics and to distribute the task to warehouse robotics and to have it in the end then confirmed by a robot is to have a handling unit warehouse task in place. And then this can be distributed. But that's not the only thing we plan. Of course, as we are launching a new product, we are also thinking on the roadmap already, what will be next steps. And one of the next steps after implementing some EWM use cases is to also connect it to the DMC, to the digital manufacturing cloud. So that's what Florian also mentioned. If we're talking about work in progress transports, for example, work in progress transports between different production supply areas that are then not managed in EWM because the stock is not posted, goods received to EWM, but which are purely managed within DMC. This is also connected directly to Warehouse Robotics. And beyond that, 2023 and beyond, we would also like to then further open up the system. So of course, it is a key strength of SAP products to be integrated one to each other. But that's not the only point. We are aware that then there are always additional processes which may not be running in EWM or DMC, but which shall also be then orchestrated or completed by a robot. And in order to accomplish this, there shall then also be APIs available. So you have an entry point into Warehouse Robotics and can even create additional orders for this. So how does this look like from an architecture perspective? Which systems are involved, which components are involved, and how do they interact with each other? So as I just mentioned, we are starting with the warehouse. So we are starting with EWM, which you can see on the top left here. And Warehouse Robotics will then be the system to retrieve the open warehouse orders that need to be processed by robots from EWM. And in order to retrieve them, there's a layer within Warehouse Robotics that we call the transport or warehouse order management layer. And this layer retrieves the warehouse orders from EWM or the transports from the DMC. So both of them can be retrieved there. And then they are taken and given to the next layer, which we call the robot planning and optimization layer. Within this layer, the whole orchestration takes place. So we need to somehow plan, optimize, and orchestrate which robot should take care of which order. And in order to do so, we do not want to distinguish between a robot which does purely EWM tasks or purely DMC tasks, but robots should be able to receive orders from both applications. And of course, also via APIs from any third party. And then there's, of course, an additional layer, which is probably the most important layer in this scenario, and that is the robot control and interfacing layer. So this layer is the actual part to interface to the different robots that will be in place. And we distinguish here between three different scenarios. So one scenario, that is the one you can see on the right-hand side, is to directly integrate with the robot. So there's nothing in between, but we can directly call the API of the robot and trigger the movement of the robot to a certain place, for example, to pick up a handling unit and then go to the destination bin to drop it there. But there are also two further scenarios, and in these scenarios, there's a fleet management system involved in between. And this fleet management system will be then the point that is communicated to, which can then further distribute the warehouse task, or warehouse order, or the order in general to the actual robot. And the same could happen for a fleet manager applying with the VDA 5050 standard. So both shall be supported, those applying to the standard, but we also want to be open to fleet management systems that do not comply with the standard. So, and what is very important here, and Florian also mentioned this already, in this robot control and interfacing layer, we want to be vendor agnostic. So in there, this is the layer where we want to offer a defined interface so we can connect with all of the robot manufacturers in the world and build up this network and have robot integrations for many robots directly available out of the box to talk directly to Warehouse Robotics. So to sum up a bit what the previous slide stated, so we have different integration types, either a direct robot integration or via a fleet management system. There will be an integration to robot vendors from different manufacturers. And just for you to get an idea on how this integration really looks like, so we do not plan to send down a whole bunch of orders and just let the system execute it and confirm back when it's done. The integration shall be more on atomic operations. So that would be an operation could be get a handling unit from a certain bin or place a handling unit at a certain bin, go to a named position. So these are the kind of operations, messages that are sent with between the interface of Warehouse Robotics to the actual robot. What may also be important to mention are the restrictions. So what is it that we do not want to do? Warehouse Robotics will not be involved or doesn't want to be involved in anything which is safety relevant controls of the robot. So for example, if there's a human standing in front of the robot and the robot should stop and drive around the human, or if it's an AGV, just stop and wait until the human moves. These are things which are not in any way controlled by Warehouse Robotics. So Warehouse Robotics assumes that the robot that we communicate to is able to freely navigate within the warehouse. So if we can tell the robot to go from position A to position B, the robot will know how to do so and complete this task. This is not controlled by Warehouse Robotics. And the same thing for navigation or traffic management, like making sure that the robot should drive on the right side of the lane so that a robot coming from the other side can also drive on the right side of the lane and they do not get into each other's way. So this is still completely with the robot itself or the fleet management system. Then how does the integration look like? So there are different integration options. It just moved too fast, sorry. Okay. So here we are with option A. In option A, we have, okay, sorry, it's just got stuck again. Here we are. In option A, PowerPoint is playing tricks on me. Okay, here we are. In option A, we have EWM on the left-hand side as our backend system. So that's always the case in each of those options. And EWM communicates directly to Warehouse Robotics. So there's a connection between EWM and Warehouse Robotics. This is the same for all of the three options that I will show you. What is different in those options is the way the cloud part connects and communicates to the edge part. So in option A, we have actually one edge per robot in place. So you could really imagine that it either runs directly on the robot's hardware or there's a small, like a small PC mounted physically really on a robot on which the edge part runs. And this, of course, has the advantage that if there's an edge directly on the robot, the edge part of Warehouse Robotics can buffer a certain number of warehouse orders that are to be processed next from this robot. This can then be configured in the backend system. So how many robots, how many warehouse orders shall be stored on one robot? And therefore, this is a very stable connection. So even though we are working with the cloud system, we know we are in logistics execution, but still we can keep the desired number of warehouse orders locally on the edge part. And the edge part then communicates directly to the robot. So it would tell the robot to drive to a named position and pick up a handling unit, and the robot confirms it back to the edge part. And the edge part will then, of course, confirm back this to the cloud part, which will then communicate it to EWM. So in the end, in EWM, the warehouse task can then be confirmed. So scenario A, we have one edge per physical robot. In scenario B, which is the next scenario, we still have an edge part involved, but now we only have one edge site in total, which is located at a customer site. So there would be probably one edge at the customer's warehouse. And now, so now there's not an edge directly on the physical robot. So this has the drawback compared to option A, that in case the robot loses Wi-Fi connection, it doesn't know how to continue. So it would always need to be in a Wi-Fi to be able to communicate with robotics, or to communicate to the fleet management system, which will then communicate with the edge part. Of course, it has the advantage that the architecture is a bit simpler than in option A because we don't need as many edge parts. We only need this one edge part in here. But therefore, it is not as resilient as option A. And the third scenario, option C, in this scenario, there is no edge part involved anymore at all. So of course, this has the easiest architecture of all of these scenarios. So there's no additional part involved at all. So the cloud can directly talk to the fleet management system. However, of course, then there's the drawback that nothing can be buffered or can be stored locally on an edge directly at the customer side. So we need to rely that there's a stable internet connection in this scenario. However, there may also be scenarios in which this is a very relevant case, and that is if, and for some vendors this is the case, the fleet management system actually runs in the cloud. So some robot vendors have a fleet management system which is operated in the cloud. And of course, in such a scenario, it would not make any sense to have an edge in between. But in such a scenario, you want to communicate from the cloud to the fleet management system in the cloud. Okay, now let's have a look at the roadmap. So what are the topics that we plan for Warehouse Robotics? So as I mentioned, the first release is planned for May this year. So therefore, the first column is, of course, now the very interesting column because it tells us what to expect in the first release. Of course, it starts with the robot integration. So we need to offer ad hoc onboarding of different robots, and that shall be vendor agnostic. So we do not want to focus on one vendor or a small collection of vendors, but it shall be vendor agnostic so we can connect to any robot from any manufacturer. And the integration will also be to EWM, so there will be resource transparency. So each robot will be reflected as a resource in extended warehouse management. The warehouse order assignment needs to take place. So all of this is based on EWM resource management. So we leverage the resource management available in EWM based on queues and resources and queue sequences and so on, and use this to assign the warehouse order to a robot. But then there will also be a basic optimization taking place in warehouse robotics to assign it based on robot-specific criteria. The next topic is the warehouse task processing. So as mentioned, we want to process handling unit warehouse tasks with the first release, so moving the pallet from bin A to bin B. And there will also be error handling in place. So I think this is also quite an important topic because in case such integration to a robot is not done via Warehouse Robotics, via standard integration, but on a customer project, this is something which always drives up the effort a lot. So you need to think about what do we do if the robot is not able to pick up the HU from the source bin because the source bin is blocked, or the handling unit is too heavy, so how to proceed. What if it cannot place it on the destination bin because the destination bin is blocked? So all of these things need to be considered in the error handling mechanisms. Then there's a monitoring in place, so we can monitor the status and the operating parameters of the robot. But we can also monitor the orders. So which robot is currently working on which order, how much is the progress, and we can also see things like the battery status of a robot in here. Then there will be some housekeeping functionalities. So we also need to define a basic battery management. So when should the robot really go charging? And of course, here we also want to consider the number of warehouse orders that are still relevant. So if there's maybe only one warehouse order left, even though the battery is below a certain percentage, we could still go charging. We could still finish the warehouse order before then going charging. And there shall also be an idling behavior defined. So what should a robot do if it currently has no warehouse order assigned? Should it just keep standing where it currently is? Or should it go charging, or should it go to some kind of parking lot? Because of course you do not want your robot to be standing in the middle of the aisle of a warehouse. And the EWM integration will of course also be part of this first release. So by EWM integration, we mean that there will be a standard integration to EWM, that to different versions of EWM. It shall be also supported to connect to EWM 9.5, but also to some of the most recent EWM and S4HANA releases. And with this integration, we can retrieve the warehouse orders and warehouse tasks from the backend and confirm back to the backend once the robot has processed the task. And we can also link and synchronize the robots with EWM resource management. In the next release, there shall be an improvement to the warehouse order assignment. So we want to optimize this for travel distance reduction, so to further leverage the capabilities of the different robots. And we are also thinking of integrating analytics. So of course, we already have some KPIs in EWM backend, but it may also be interesting to have very robot-specific KPIs within warehouse robotics. So how much has a robot really been utilized? What is the on-time rate? How many robots were in use? What is the charging behavior? And so on and so forth. This is something to be considered for one of the next releases. And then I already talked about it. The DMC integration is something we are planning. So we cannot only retrieve warehouse orders from EWM, but also receive WIP transports from DMC. And this is linked to the next topic, which is the cross-application robot. So a robot shall not be a pure EWM or a pure DMC robot, but it shall be a cross-application robot. So it can receive orders from different applications, and we can orchestrate and prioritize across those applications. And we will then also deliver an integration not only to EWM on-premise or private cloud edition, but there shall then also be an integration to the public cloud edition of EWM. And there are future topics, and of course, I mean, since it's a new roadmap, since it's a new product, there will be many more roadmap items to come in the future. So I believe when you launch a product, then there are always things that we can learn from our customers, from our partners after the launch, and there will be more things to appear on the roadmap. But there are already some things that we were thinking of today already, like integrating external devices via APIs, or also process external orders via APIs, so to receive orders from outside. Offer extensibility within warehouse robotics, like a developer extensibility. So when there's the assignment within warehouse robotics, there could be something like a body to further influence the assignment of which warehouse order shall be assigned to which robot. Or thinking about events. So if a certain action takes place, that we can react on those. Also, an extended process flexibility. So maybe during the way redetermine the storage bin if the destination bin is blocked. Or physical inventory could be a completely new use case that we didn't consider yet, as there are also some robots which can detect empty bins. But this shall be almost the last slide. So to sum it up, what we believe are some of the key points that make warehouse robotics unique is that we have this out-of-the-box integration with EWM, with predefined scenarios, starting with moving handling units in different warehouse processes. It will be easy and fast to implement, to operate and scale, to add robots from different vendors on the fly, so to avoid big integration projects. And even when you just a single robot, there shall be acceptable costs for doing so, without having to do a customer-specific project just to integrate one robot. And it shall be vendor agnostic, so you can manage heterogeneous fleets. So you don't need to build a new integration for each different vendor, but you can have one kind of integration via warehouse robotics, and they will be orchestrated and monitored within this one solution. And all of this shall, of course, be done leveraging EWM. And maybe this is also important to understand because we have different solutions in this area of warehouse automation. which we believe is relevant for what use case. And if we're talking about conveyor belts, for example, then of course it still makes sense to use MFS, the material flow interface. For anything like forklifts or human pickers, the RF framework is still available. But if we are talking about robots, AGVs, AMRs, then from May on, the clear recommendation from our side is to go for warehouse robotics to make that integration happen. So that would be the last slide. Thank you very much. And yeah, I think we still have some time. So we are open for questions.
Yeah,
Thank
Christian.
you very much, Christian. Thank you very much.
In the meanwhile, I had a
Yeah,
look
go ahead.
already. There are some questions in the chat already, and I would just take it from the beginning. Um, a very good feedback, let's say, from the very first slide I shared was, let's say, how the warehouse robotics should replace a automated high bay, right? Because here the target is to utilize, let's say, horizontally the space. And yeah, that's true. That's from a first point of view, not directly where the robot would replace it. Maybe it would be better to even choose an AGV, let's say. AGVs are there for a long time as well, which are basically doing the movements from A to B. There will be, or there are already some concepts on, let's say, even, let's say, moving, for example, racks, then we are a little bit utilizing the height, but true, an robot might not replace an automated high bay. It was more to showcase that in the warehouse environment we are used to have, let's say, these robots or a kind of robot working and directly communicating with the backend system. I hope that is answering the question. And the second question was about the communication method between EWM and the warehouse robotics. So we place our integration here on the normal APIs we provide, so OData APIs in the version 4. This is basically where we place the communication between, let's say, warehouse robotics and EWM on. Any questions to that?
Uh, is it okay if I can ask this one? I think I have one doubt. So, Prabhjot, shall I ask a question?
Go
Florian?
ahead, please. Go ahead. Go ahead.
Yeah, so I think one doubt which I have is like the moment it's basically based on the warehouse order level which is getting transferred, right? So
Yes.
if the let's say if a stock is in between from the point A to B, and at the time if in the system level if somebody is doing any changes of the resource or something like, how is it like locking that task or warehouse order? Is it there is any field to block that warehouse order so that the warehouse user
Yeah.
or somebody doesn't make any change?
Yeah, exactly. I think it's the same behavior as we have it with the material flow system. There will be, there's a flag basically which is indicating that this warehouse order is now transferred to the uh, warehouse robotics, so that you can at this moment in time not change it, right? So that would be, as you mentioned, quite strange if you just change it in the meantime.
Hmm.
Yeah, it will be under control of the subsystem exactly. So it will be locked to just cancel or confirm it in the warehouse monitor. So that will not be possible exactly.
Okay, okay.
Will we have specific queue determination? I think that goes a little bit into the same direction. So we really based it on the existing backend functionality. So the robot will be reflected as a warehouse resource. So as you usually do it with your forklifts and your users, you basically model them in EWM as a resource. And the same we do with the warehouse robotics. So a robot will be represented as a resource. And it's not that we have an anonymous resource. So we really have, let's say, if we have 10 robots, we have 10 resources in the backend system. And then it's the normal setup. You can then assign warehouse orders to queues, and these queues can be linked to the resources which are capable to work on those. So it's the normal behavior of the backend system.
Hmm. Okay, so Florian, we have one question here, which says that would there be any item-specific instructions given to robots? For example, if the item is fragile, so it has to control the speed, or it has to, apply a certain amount of force, or can there be an adjustment based on the type of product it can handle?
I would say yes, based on EWM resource management. So in the end, as we are reusing EWM resource management, and you have all the freedom in the world to assign which resource is capable to execute which warehouse task, so the assignment takes place earlier. There you can do it. So if there's a special robot which is only allowed to handle such fragile items, that can be done based on this.
I think it
Okay,
was more in the terms of controlling the speed. So in principle, it is capable, but for certain items, it should just drive slower or something like that, right?
right. Correct. Yeah.
This one, to be honest, we haven't considered until now. We really start, let's say, with a first easy setup. So this one,
Mhm.
yeah, let's see if we bring it in the next releases, if this is really required. So we haven't heard about that requirement so far.
Okay. Okay. And how about the companies like ours who need to who want to test this particular product? So how we can really dig into the system?
So I think we are currently still evaluating a bit on this because we have some customers, of course, also interested in this, and we also want our partners to test it. But probably one of the best ways forward would be via a test license of the BTP, because
Uh-huh.
it will in the end be running on the BTP. So if you can get a trial license for the BTP, then it should also be possible to test Warehouse Robotics, of course, without modifying any productive data. So it should not be or may not be connected to a productive system, of course, then.
Yeah. Okay. And on which particular date it is getting released in May?
I think we don't have a concrete release date so far.
Okay. 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 So
So
let me
I
go to.
just read another one, which I think we answered it. Are we going to utilize the technical framework of the MFS? So no, we don't. We are even not communicating via telegrams and TCP/IP as mentioned. We are going via the OData APIs.
Yeah, and
The
to add
next,
to this, maybe, sorry, just add to this, and it's
yeah.
all, I think maybe we didn't mention this enough, it's all Kubernetes based. So it's a very different technology stack.
Mhm.
The next one is a very good point. Optimization takes consideration of travel distance, interleaving, etc. Considering we don't assign a specific warehouse order and leave up to optimization to do that assignment based on the current robot position. Yeah, to be honest, this was just recently discussed that this would be one of the optimizations you might have seen on the roadmap, that there is already a kind of optimization of warehouse orders. And yeah, it's not in the first version, but for sure we plan for such things, right? But there's even other optimizations planned for the backend environment, so for EWM as such, to basically reduce travel distance even more. I mean, it's even important for manual operations, for manual forklift drivers, right?
Mhm. And how about the exceptional scenarios? For example, if the bin is blocked or the bin is full, or probably the robot cannot even reach to the particular bin because of the any roadblock. So any exceptional scenarios are we considering?
Mhm.
Christian, would you like to tackle that?
Yeah, it's one of the topics on the roadmap actually for the first release already. So yes, we want to handle those. I mean, of course, the devil is in the details, so I don't want to explain all of those scenarios in detail now. That would take up too much time. But
Mhm.
for example, if you cannot drop it at a destination bin, then the robot will be instructed to bring it to a clarification bin, and there will be notification available in Warehouse Robotics to some operator. The warehouse order is moved to an error queue. So these kind of things are taken care of.
Okay, and then another question. So how about its integration with the other warehouse related products like warehouse insights. So will it be directly integrated to warehouse insights, or it will happen only through via EWM?
So currently, there's no direct integration to Warehouse Insights planned, but but to EWM. But of course, there wouldn't be an indirect integration, let's say, right? So if you're using Warehouse Insights and Warehouse Insights optimize the warehouse order for you, this will be reflected within the EWM resource management. And then the EWM resource management is again used from Warehouse Robotics. So there's this indirect integration, but there's no direct communication at this point.
Okay, okay. And then since you've mentioned that you will be using some edge technology, so I think that would be very beneficial at the time when there is no communication in the warehouse, or there is a lack of Wi-Fi network in the warehouse. I think can you explain a bit more onto that edge technology?
Yeah, basically that's the whole idea, I think, about the edge technology, so that we have a kind of edge cluster, and then you basically have the edge device, and you deploy a certain number of missions basically. So it's these smaller pieces which should be executed down to the real robot, which can then independently even of network connection operate on these missions. So that is, I think, the last, which was related to that point. If we run out of a Wi-Fi with your robot, then he will still continue, and just when he enters back into the network, then he could communicate back the execution and confirmation of these steps, right?
Okay. And how about the licensing cost? Probably, I think it would get clear in May itself. I believe so.
Yeah, right, Florian. I don't think we have any pricing that we can communicate yet, but
Mhm.
then latest with the product release, that will be
Exactly.
clear.
I think if I'm not wrong, it all started with the the open ecosystem. It was open for the entire community on the GitHub, because I've read a couple of blogs where it was mentioned that it is open, and then it could be it is placed in the GitHub, and then it is open to be used by everyone. I think this is the same product transition which is happening.
No, basically, I think that was the beginning. You are right. That was a kind of study together with Google Cloud Robotics, I think they called it. But basically, Google stopped this project and didn't investigate it further. And yeah, we are basically built our complete own product, not placed on any coding of this open source what was published.
Okay, okay, okay.
There's a good question, I think. What about, uh, or let's say maybe it's not directly linked to it, but the question I think might be valid, or we haven't mentioned that. I think that, it's obvious that there's a back-end capability needed to communicate with the warehouse robotics, and that might be interesting because especially for our existing customer base, that we plan to have it available, let's say this EWM part, to be downported to 9.5 even. So you can start using warehouse robotics together with EWM 9.5 and higher releases, especially on the S4 stack. I think that's worth to mention.
Okay. I think we are running out of questions now. So probably if there are any further questions, I'll pass it on to you through an email, and then we can circulate back. So thank you very much, Florian and Christian, for taking out time and explaining about the new product to everyone in the community. Thank you very much.
Thanks as well.
Thanks for having us.
One
Thank you.
quick
Thank you.
question. Will this
Yeah.
presentation be shared with the audiences? The slide that was presented?
I think so, right, Florian?
Yes, I think we can share it. Yeah.
Yeah, so I can get it from Christian and then I can circulate.
Thank you, Prabhjot.
All right. Thank you very much, everyone. Thanks for taking our time. It was pleasure meeting you again.
Thank you, guys.
Thank you,
Thank
Florian.
you.
Thank you.
Yeah.
Bye.
Thank you.
Thank you.
Thanks,
Thank you.
Prabhjot. Thanks,
Bye.
everyone.
Bye bye.
Thank you. Bye.
think so.